This math concept is going to be talking about least common multiples. Least common multiples. Now, what are least common multiples? We are going to designate that with an abbreviation as the LCM. So the LCM is going to find a factor or a multiple or a grouping of a series of values, a sequence of values, that is going to be the smallest one that can happen. And the reason we want that is, again, when we are dealing with math and mathematics, we want to keep our numbers as small as we can. There's going to be times where we multiply things together, combine them together, we're just going to end up with these huge complicated numbers. And we need to make them simpler to make our lives easier. So the way we do that is we first off have to have a series of numbers. So I want to find the least common multiple of the grouping of numbers of 16, 99, and 104. Now these are going to be answers in some sort of equations that we're working. They could be denominators and fractions. They could also be values or the magnitudes of a series of numbers that are in a simultaneous equation scenario, which we will get into those a lot later in the semester, but we're going to find them the same way using denominators or simultaneous equations. We want to use this least common multiple method. And the reason for that is if we take these numbers and if we just brute force them to find a multiple, so brute force multiple, we basically just go into it and we say, I'm going to take 16 times 99 times 104, because that is a multiple of these series. So 16 times 99 times 104. That's going to give us a value of 163,736. So a huge number, and it's a very ugly number. Okay, it's got 6 digits on there. It's got a lot of things going on with it, but we brute force multiply it together, we get this value. Then we're going to take that number and we're going to apply that in future steps. A lot of the times it's going to be multiplying either the denominator or each of the values in a simultaneous equation by this number, which then is going to make it even bigger and then bigger. And sometimes we have to do this multiple times and we end up with just ridiculous numbers that we have to try to use and calculate for. So the way that we do this to make it a little bit more elegant and a little bit more simplified and less work for us on the back end is we use this least common multiple method. So what this is we are just simply trying to find what are my factors of these series of numbers, whether it be 3, whether it be 4, whether it be 99 numbers, it does not matter. So we're going to find out what are the factors of these guys. So I'm going to take 16 and I'm going to break it down into its factors. So 16 is going to get broken down, and we're going to use my tree method to get over here. So 16 is even, so we'll just go 2. That's going to give us 8. 8 is even, so we're going to go 2 again. That's going to give us 4. 4 is even, and so we're going to break that down into a 2 and a 2. So what we end up with is 16 broken all the way down into its prime factors is 2 times 2 times 2 times 2. I know this might seem a little redundant and a little bit of a exercise and a lot of work, but just stick with me and I promise this will make sense in the end. So there's my 16 factors. That's what it breaks down to. All right, 99. Done this number a couple times already. So 99 I know is going to break down into 9 and 11, and that 9 is going to break down into 3 and 3. So now here is 99's factors is 3 times 3 times 11. And those are my prime factors. Okay, the next one I need is 104. So 104 is going to break down, and we're going to break it down into 2 because it's even. So I get 52 times 2. We're going to break 52 down. And again, I'm going to take the easy number because it's even. So I'm going to pull out a 2. That's going to leave me with 26. And then 26 is going to break down, it's even, so there's a 2, and that's going to break down to 13. Now 13 is a prime number. So my factors of 104 are then going to be 2 times 2 times 2 times 13. So now when I'm going through, I'm trying to find the least common multiple, the smallest value that all three of these numbers go into evenly. So now what I'm going to do is I'm going to start creating a list of all the factors I have to make these numbers. So for 16, I have to have 1, 2, 3, 4 2's, all multiplied by each other. So my least common multiple has to include 1, 2, 3, 4 2's. And now 16 is happy. Okay, now I'm going to look at 99. So 99 has to have a factors of 3, 3, and 11 in it for it to be happy. Right now, there is no 3, 3, or 11 in there. So we have to add them. So times 3, that takes care of this one. Times 3 takes care of that one. And times 11 takes care of that one. So now 99 has got factors of it that it needs, a 3, 3, and 11, in my final answer. Now the last step, 104. It wants a factor of 1, 2, 3 2's. So if we look, we already have 1, 2, 3 2's. And it's okay that they're being used by the 16. They're going to share them. This is where the common part comes of this least common multiples idea. So those 3 2's are already taken care of. We already have those three factors. The only thing we're missing now is a 13. So then I have to multiply this by a 13, and now all the factors for 104 is contained somewhere in this least common multiple calculation. So 104 has everything, and it's now happy. The last step is just simply combine all of these values together. So my 2 times 2 times 2 times 2 times 3 times 3 times 11 times 13, that's going to add or multiply up together, and my least common multiple of these values is 20,592. Now, if we look at it, we're like, but that's not really a great number either. It's 5 digits, but we got to remember it's at least smaller than this guy, this brute force method. Okay, so in the end, our answers, yeah, they still may get bigger faster, but they're going to stay smaller than this guy. I mean, this is an entire order of magnitude smaller. We have 20,000 versus 160,000. So really, we're even 80 times smaller than what this number is, or 8 times smaller. So our answer is going to be 8 times smaller in the end, and it's going to cause 8 times less of a problem and a headache later on. Now again, we can do these for any of these numbers. Okay, so let's look at another example. So for least common multiples, I want to simply find the least common multiple between the numbers 2, 4, and 9. Now again, if I take the brute force method, I'm going to go 2 times 4 times 9. So I'm going to get an answer of 72. This is using brute force. We're going to make them be multiples without any kind of manipulation. So brute force multiple. Now 72 isn't bad, but by using the least common multiple method, we can shrink that down and make it even easier to work with. So 2, the factors of 2 is just 2. The factors of 4 is 2 and times another 2. The factors of 9 are 3 and a 3. So then when I write out my least common multiple, 2 needs 1 2 in it. 4 needs 2 2s. We already have 1, so we add in our second. And then 9 needs 2 3s. So there's my 1 3, there's my second 3. And then when I multiply everything together, I get 2 times 2 times 3 times 3, and that gives me a total of 36. So it is a smaller number than just brute forcing them together. 36 is less than 72, which is going to help us further reduce values later on down the road when it comes to these numbers and having to reduce them later on. So least common multiple utilizes the principles of prime factorization as well as just getting the flat out multiples of these values. Now we could have already looked at this and known that between 2 and 4, we're going to have a 2 in our least common multiple, no matter what's going to happen. And between these two, we're looking at a value of 8. If 8 was going to go into our next number, then we could use 8 as part of our values and things like that. We don't have to bring it all the way down to the primes, but the primes do simplify it out, and it just spells out everything that is contained in this number from A to Z, 1 to 92, whatever it is you want to look at it. Prime factorization just spells everything out from the start to the end of everything that this number contains, and then we can go back through and manipulate what we need to. And we don't always have to go down this far. Sometimes we can find a common value and just take that instead of applying it to everything else. And that's another tool that we'll learn later on as we get going when we start looking at simultaneous equations and things like that.